Welcome to the Technical Writing Success Video Overview by Robbins, where we help you get smarter than your competition. Today we are going to be diving into the absolute cutting edge of computing, all based on a really fascinating article by Kurt on LinkedIn called The Quantum Leap, Computing's Next Revolution.
All right, so here's our game plan. First, we're going to talk about why our current computers are hitting a wall. Then we'll get into what this quantum leap is all about. From there, we'll look at the insane hardware involved, the global race to master it, and finally, what it all means for you and me. So let's kick things off with a big question. Why do we even need a new type of computer? Well, it turns out our digital world is running into some serious limitations. You know, for the last 75 years, everything, and I mean everything, has been built on this really simple idea. A bit of data is either on or off, a 1 or a 0. It's powered our entire modern world. But here's the catch. There are certain problems out there, especially in medicine and materials science, that are so ridiculously complex, our most powerful supercomputers today would literally take thousands of years to solve them. We've basically hit a ceiling. So how do we smash through that ceiling? Well, it all starts with a completely new building block. We have to go from the classical bit to something called a qubit. Now, a normal bit is always stuck in its lane. It's either a 1 or a 0. A qubit, on the other hand, can be a 1, a 0, or, and this is the part that changes everything, it can be both at the exact same time. This is where things get kind of weird and wonderful. Okay, so you're probably wondering, how does being a 1 and a 0 at the same time actually give you all this incredible power? Well, it all boils down to two really strange but super powerful rules from the quantum world. First step is something called superposition. And yeah, that's the fancy word for what we just talked about. It's this mind-bending ability for a single qubit to exist in a combination of states all at once. So instead of having just one value, it's like it's holding a whole range of possibilities all at the same time. The second key ingredient, that's entanglement. Now this is where it gets even crazier. When you link two qubits together, they become connected in this really deep, mysterious way. They act like a single system, no matter how far apart they are. If you measure one, you instantly know the state of the other, even if it's on the other side of the galaxy. It's this perfect, spooky teamwork that just multiplies their power. Okay, let's make this real, because this is the game changer. With 3 regular computer bits, you can represent just one of 8 possible combinations at any given moment. But get this, with 3 entangled qubits, you can represent and work with all 8 of those combinations at the exact same time. That's not just a little faster, it's an exponential explosion in computing power. That right there is the secret sauce. So this all sounds amazing on paper, right? But actually building a machine that can pull this off, well, that has been an absolutely massive engineering challenge. You know, the idea's been kicking around since the early 80s, thanks to the legendary physicist Richard Feynman. But things got really serious in 1994. That's when a guy named Shor figured out an algorithm that proved a quantum computer could, theoretically, crack the encryption that protects, well, almost everything online. All of a sudden, this wasn't just a physics curiosity anymore, it was a major global security issue. And the main reason it's so hard to build one is that qubits are just unbelievably sensitive. They're so fragile. The slightest little disturbance, a tiny vibration, a stray magnetic field, any kind of noise can make their delicate quantum state just collapse. And poof, your entire calculation is ruined. So how on earth do you protect something so delicate? Well, the solution is staggering. To keep the qubits stable, engineers have to create one of the coldest places in the entire universe. These machines run at -460 degrees Fahrenheit. Let that sink in. That is colder than the blackness of deep space. That alone gives you a sense of the incredible engineering at play here. But even a challenge that is literally out of this world hasn't stopped a full-blown global race from kicking off. Everybody wants to be the first to achieve what's called quantum advantage. And the list of competitors is a who's who of global power. You've got governments like the United States, China, and the EU pouring billions into research. And then you have the tech titans. We're talking IBM, Google, Microsoft, Amazon. All of them are in an all-out sprint to build bigger and more stable machines. The stakes are enormous. So this race is on. Sooner or later, someone is going to succeed. And the big question is, what happens then? Because this technology is really a coin with 2 very, very different sides. Incredible promise and profound peril. Let's start with the promise, because it is truly world-changing. We're talking about the power to supercharge artificial intelligence, to discover new life-saving drugs by simulating molecules perfectly, something we can't do now. We can invent revolutionary new materials from the ground up and solve hugely complex problems for things like global supply chains or financial modeling. The potential upsides are just massive. But then we have to flip that coin over. And this brings us to the final critical question. The exact same power that could help us cure diseases is the same power that could shatter the encryption protecting our banks, our communications, our entire digital society. So the question we're all left with is this: what happens when a machine can do both?
And on that thought, we'll wrap it up for today. Thank you so much for joining me. This is the Technical Writing Success Video Overview, where we help you get smarter than your competition. If you found this valuable, please do us a huge favor and subscribe to the channel. And of course, every like, comment, and share really helps us reach a wider audience. Thanks again, and we'll see you in the next one.